Hello, hi. And, I'll begin with a bit of a relevant aside to my own project oriented goals. Okay, but it's not relevant to the topic I'm going to discuss at this time. So, years ago, when during my second semester in the Department of Chemical Engineering, University of Toronto, the first semester, I flunked one course, got two B minuses, three courses. The second semester, I made an A minus, a B plus, and this course I got a B. And various persuasive tactics. I wore a short skirt and went to the professor. But the Professor Trotz, would have no sort of persuasive, um, endeavor on my part, persuasive goals on my part to I thought, because I had done well on the final and the midterm, I had not done too well. I had not scored the required 70, but I think I'd gotten something like 35, 40 or something. But he had not played fair. He had one question which was for 60 marks or something. You get the question wrong, you're bound to flunk the course. But the final, he was very good. Be a chance. So with a really short skirt, and but he would not succumb to my charm. He said, if you had done, gave a little note, if you had done well on the midterm, then you would have gotten an A minus. But and sent it to the office, graduate office. And things worked out, and I officially began a full-fledged program in my Master of Engineering thesis. Yeah, I've because University of Toronto is really strict, right? I had fulfilled the requirements for my undergraduate degree because there was one course left over, and I did it in Arizona State. Anyways, that's done. This is what. Now this is. Let's come get a closer look. I should have. I should have done this. This is a dessert floor fork and a dinner fork. Here, maybe I move the computer rather than that. Dessert fork and a dinner fork. And this is Archimedes' principle. One third the distance, two thirds the distance, smaller weight, and one third the distance, the larger weight. So the fulcrum is about here, and this is because I had to see if I'm if a soup canister with an AC motor installed inside, along with an AC circuit, in a battery receptacle, batteries in a battery receptacle, etc. And I need to buy an alternator, Sator and rotor, and to get and ignition starter. I need to figure this out. So then I would get the soup canister with all this installed in between, small soup canister, something like this. This worked, but a bit. It's something like this because it's all covered, so it goes in midway through the bathtub or a swimming pool. Then the equipment inside is intact. So I thought I would do this and get the submarine going, and that's my latest. And it is really hard, all right, because anything you think of, you're programmed to think in terms of a car. And as I explained to myself and the powers that be, I'm submitting this because I was sort of informed that Prime Minister Carney may have used for this. So, he's been shopping for and then, strike while the iron is hot. Maybe the technology works. I get my elusive paycheck, and all of my research, my other projects are all published, and I paid some money. That might be nice. So he so that because he's been shopping for submarines in Germany, in South Korea, and so build our own submarines. Canada, some by some, because we kind of use up the time, I guess. But for 12 submarines, it's a lot of money, and Canadians could put it to other. He knows all about it, budget and everything, right? He knows all about it. We can read up on his budget. Excuse me. So by Gayatri V. Sitaram. All right, I'm going to sources of reference, Schlichting's boundary layer theory, and then a very nice website which kind of tells you from the marineinsight.com. It's a naval um, uh, architecture. So it's an introduction to submarine design, and it talks about tanks and torpedoes, etc. But that's all part two. Just because either an object floats or sinks in water, so to keep it underwater at a mid level, at a place where, at a spot where the pressure, there's no turbulence, but the pressure is very high. 300 meters, 150 to 300 meters, as the internet says, there's no turbulence actually. I mean, the water is all calm, but the pressure is very high. And you can calculate the static pressure, the dynamic pressure, rho gh, rho v squared by 2. So my first thought, my educated guess is that a combined study of the boundary layer theory for the surface and volume of water close to the submarine would be going through turbulent water where the viscous forces are very low, and away from this boundary layer is a laminar turbulent water which has the inertial and viscous forces at an equivalent. This would help in the design of the control engine, along with the study of the other momentum transfer area. Well, heat transfer would be needed, torpedo, etc. I mean, how to eject it out and fire it and that sort of thing, and a few mechanical engineering areas. My second thought, except on the surface of the water and below, for about so there is no turbulence, the 150 to 300 meters, I already spoke about this. The internet says turbulence at the ocean surface is a shallow upper level phenomenon that has little impact on the deep ocean. The water motion from surface turbulence, like wind and waves, decreases exponentially with depth, dissipating into the water column and ceasing to have a significant effect at a certain depth, usually 150 to 300 meters below, in the open ocean. For the submarine, 3.3, for the submarine to get lifted up from the depths of the ocean or sea to the surface of the water, there could be a hydrodynamic lift which is at play. And so that's what for before I go to point four, I'm just going to see if I can. Oh, this is not. This is not. This is not going to work. This is only for vertical lift. No, I thought some magnetic force that could, some magnet operated weight, which could sit at the fulcrum of the submarine, and then on both sides, and then it goes up. I'm just thinking. I don't know how to make it. There are references which I have to study, but at first let's get this soup canister going inside the water. So a combination of a circular cylinder and airfoil for the behavior of the boundary layer may be the key to some of the solution. So both of these have been discussed in Schlichting, and I'll show you pictures. Would the study of the velocity profiles for the above and four lead to a knowledge of net force required to operate the submarine? And it would be a mechanical motor that would generate the net force plus over with that is required. 6, breathing air would be a problem. So possibly decomposition of the carbon dioxide breathed out and recirculation of the oxygen, and some being pumped in from supplies would be an option. For water, for drinking water, it could be sea or ocean water desalinated and purified along with supplies from board. 7, as an analogy, I considered a car, and to move 20 kilos of a car mass, you need a velocity of 120 kilometer per hour or 33.33 meter per second, and this would generate a momentum force of 666.6 kg meter per second, and this could, when increased in velocity, generate the required newtons. And say I were to accelerate the 33.33 meter per second velocity to twice the original velocity, or apply an acceleration of 66.6666 meter per second square, I would have a force of twice the momentum force, which is equal to 1333.2 newtons. Studying reference one, I have, and I said I'd show you pictures. This is, and I come and this is and I check this out. All right, the soup canister on the in the sink, but sink, unless you have a sink plug, really hard to. So those are the streamlines, etc. So it's really hard to do this experiment if in a sink, because water's going on. So we have a tap extension, so that the tap comes out like this, and so I just sprayed on the soup canister, and I could clearly see the streamlines. They're not quite like this and like this, but this, they come out, spray out, or when you spray this on top of the soup canister, and or the tap runs on the soup canister, and then you have clearly the boundary layer at this laminar flow speed, and in the bathtub it floated, the soup canister floated, and there also we have a tap extension, very nice to spray tap extension. So the streamlines, of course, with the spray, yeah, no biggie. But then what happens to soup canister? It travels forward for some time and then starts to move backwards. Interesting phenomenon, isn't it? Completely true to what Schlichting thought of. Okay, so backflow. So backflow, and then what else do we have here? Do I have here? To understand, to understand this concept, I tried a little, well, experiment. I spoke about the experiment, so that's what I have. This is to share with and a tennis ball, and then the soup canister. Soup canister is cylindrical, right? The tennis ball is spherical, and so we have a Roman style bath. Oh, you know it from my videos, Roman style bath. The submarine cannot float backwards and must have some form of pressure applied to it to prevent it from floating backwards, unless it's backing up, of course, reverse gear. It occurred to me that a propeller would prevent backwards running of the submarine, for the propeller would propel it forward, and to generate the momentum force, I need an AC motor. The AC motor would have an AC circuit which would generate sinusoidal waves, and it would consist of a battery churning out current. And so battery would have to be in a battery receptacle, and an insulator maybe that could act as a resistor and a capacitor, or I skip both. I just have the battery. This would generate an electric force that would operate the propeller, which would possibly act as an ignition. And to keep it in running mode, I would need a rotor and a stator. The latest on pricing in Home Depot carried on this is $329 plus tax, a little above my range, but there's Canadian Tire, which has an auto shop. So let's hope. And I called up this other store, Minute Muffler. He said, go to the Canadian Tire. So they begin at $44.99 or something. But I called up this auto shop. He says $250. And he just caters to cars. But 11, I thought that I would buy a soup canister and see, because after some tinkering with the above, if I can make it and go and I share this with you. Go in mid water level in the bathtub. From reference one, boundary level or boundary layer on an airfoil. And you have all this. You have all three types of flow. And Reynolds number is all, and then okay, this is separation of the boundary layer. The text above says that the thickness of the boundary layer reduces to almost zero if the length of the body, L, increases and the Reynolds number in this case tends to infinity, which means that the viscosity is really low and the friction or viscous forces are negligible. The inertial forces are high. Typically, this means a high velocity as well, and this matches the existing parameters on submarines. Long body, right? Internet. Pressure is constant across the boundary layer, perpendicular to the surface, but its pressure gradient along the flow direction dramatically affects the boundary layer's behavior. A favorable pressure gradient, decreasing pressure, accelerates the flow, while an adverse pressure gradient, increasing pressure, slows it down, potentially causing the flow to separate from the surface, which creates turbulence and can reduce lift. So, remember, the next time you take a cruise around the harbor front, we did this in Savannah, Portland. I think we did it in Hawaii as well, and all other places, New Orleans and other places, not to mention Toronto, of course. Always Toronto's a favorite, right? Our town, my city. So then you'll notice next to the bend over the deck, that mm, uh, I think that's called the poop deck, right? When you come out in a ship, I guess, but in a boat, I think it's just the deck, and you bend over the railings, you see the water, the boundary layer clearly. All right, they're close to the ship, and then it's turbulent, and next to it it's calm waters. If it's choppy waters, that's different. Otherwise, I don't observe during choppy waters. Do they merge together, the boundary layer and the choppy waters? This is an interesting exercise. Next time I'm going to go, but I don't want choppy waters. So, anyways, so my calculations: the static and dynamic pressures at the submarine level with the velocity being 33.33 meter per second are 284.8356 atmosphere and 53.7582 atmosphere or kg per meter per second squared. I took the formulas. Rho g h, and h is equal to 300 meters and rho b squared by 2. Obviously, you would need an excess of oxygen being made because it's hard to breathe when the pressure is so high. But this has all been done before. People have gone around in submarines, etc. But this is for me to understand and share it with you. All right, dear viewers, at the boundary layer, the Navier-Stokes equations break down. For an incompressible flow, the equation of continuity says that the velocity of the submarine in the y direction is constant. Well, del v x by del x plus del v y by del y plus del v z by del z is equal to 0. And, del v y, it would be a constant. Del v y by del y is equal to 0. And then, integrating vy is, so it's a constant. From transport phenomena by birds, as Professor Trask used to say, he was Estonian, Canadian, Bird Stewart, and Lightfoot. All right, I have to say this all the time. It never going to grow old on me. Some things never grow old on me. This bring back my happiest days. The equation of motion in rectangular coordinates, although the entire exercise should be in cylindrical coordinates, y component rho multiplied by del vy by del t plus vy del vy by del y is equal to minus del p by del y minus del tau yy shear stress by del y plus, people who are chemical engineers know this equation. It's a piece of cake. Plus rho gy. So substituting values, 1000 rho kg per metric cube multiplied by 33.33 by 3600 seconds, assuming t is equal to 1 hour. The submarine is running for 1 hour, plus 33.33 squared by L is equal to minus the pressure 338.5938 by L plus mu Viscosity del square Vy by del y square plus 1000 multiplied by 9.8 rho Gy, right? And bearing in mind that 10 kilo per meter per second is 1 points at T equals 25 degrees centigrade. So converting all this, and calculating the quadratic equation, the roots of the quadratic equation, I got the L as being 0.0789. So actually 0.079, but I took it as a 0.078 meter, the 7.8 centimeter. So I thought I hit a time warp and I need to study Schlichting again. So Schlichting, going to Schlichting from the plot included below for circular cylinders. This is the plot. This is characteristic values of del 1x, the boundary layered thickness, del 2x boundary layer. And so boundary layers are in front, back, on the sides. I've seen the ones on the side because I can see front, you can't really bend, you don't get a good view. Side it's better. Although I've stood in the front, maybe I've not looked for the boundary layer. And so this gives from this and the next figure, circular cylinder flow. I got this is this is for floating objects only, not mechanically operated objects. I obtained from a calculated length of 0.078 the following results. Integral method for the floating cylinder underwater or on the surface of the water, U by V leads to 80 degrees. Phi equals 80 degrees, so then Y is equal to 1.6, or 20 degrees, Y is equal to 0.65. But these are going at floating speeds, no mechanically operated. All right, so Y is longer. Y is more. I mean, Navier-Stokes does not break down. There's no boundary layer happening there. And using equation 8.40, I have U equals some meaningless value, 0.4048 meter per second, and U equals minus backflow 0.4052 meter per second. So this backflowing phenomenon, I saw this. So you can try this experiment at home. Exact solutions. So del 1, and I point out the figures. So del 1 phi, so del 1 and when phi is del 1 2 star del 1 by r star square root of v star r by nu kinematic viscosity. This is equivalent to 1, and phi equals 15 degrees. This is equal to 1 from the plot. And so you have for del 2 and tau, and so using x equals r cos theta or r cos phi, and y equals r sin phi, with my velocity of 33.33 meter per second and y equals 0.078 meter, I obtained r is equal to 0.12 meter. So del 1 is equal to, for such a small object, length is just 0.078 meter and r is 0.12 meter. So R is so it's like a disc, I guess, small disc. I think it's like a big it's like a disc. I got del 1 is equal to 0.00028 meter, and del 2 is less. Maybe it's in the front x in the x direction, and y is more. And shear stress is, because it's traveling very fast, this disc is 602218.2452 newtons per meter squared. Just to understand a Newton, momentum Newton, you should pick up your flour bag, all-purpose flour bag. It's typically 2 kilos, and then just move it for a meter, and you see the amount of force required. To move the momentum force required to move it, and that sort of it's quite a bit. It doesn't move on its own. So it's How would I lift the small cylinder of different dimensions to the surface of the water? Lift equals lift. And this is all internet. Lift coefficient multiplied by rho multiplied by surface area multiplied by velocity of the fluid square by 2. So velocity of this fluid, it's no turbulence at all, 300 below depth, 300 meter below depth. Since I don't know the lift coefficient, I say that the lift power needed for this experiment is about only 1.49 newtons. And reference 4, there's another book. It's by Norman Friedman. It's the submarine design. It's called Submarine Design and Development. And I looked into this book, and this is also a PDF copy available on the internet. I looked into this book, and it needs a detailed study. It occurred to me that the Archimedes lever may work for vertical lifts. I made an experiment and stuck. Oh, okay, so same thing. I positioned the dessert fork, and the hitches of the submarine cannot operate vertically positioned. So this doesn't operate vertically positioned. Maybe this way. We'll see if I can lift it. I'm going to come back and see. So this is 1/3, and I'll see if I can. So lift vertically. Archimedes principle. So see, such a important principle. It works for vertical levers as well, but they have to be vertically positioned. So we'll see. And so it could stay. Could stay. So work on this, and you will have a submarine. Enjoy. Thank you.